this separation process is very much a continuity subject from a mass transfer that you have learned before. Alright, so basically the separation process kena ada part 4. So kat dalam part 4 ni ada dua subjek yang sangat penting yang korang belajar. The first one is the reaction 1. Kan, reaction 1 CHE544, and the second subject is separation. Subjek lain pun penting juga, but this one we are talking about the core business of chemical engineer. Okay, sebab apa? Sebab if kesinambungan daripada mass transfer, okay, from mass transfer you have learned 3 equipment. Okay, you are talking about the design and equipment of masih ingat lagi tak? The gas absorption tower, the adsorption tower, and also the dryer. So basically inside here we have another 5 system or 5 unit op, okay, under the separation process. Okay, if you still remember inside a typical chemical plants, right, kalau kita nak masuk, okay, and then you have some kind like a pre-treatment, okay, pre-treatment of the raw material, and then it will go to the second part, which is the reactor. Okay, so reactor ni they always mention as a heart of the chemical plant, because dekat reactor ni lah the one that you belajar lah daripada dekat CHE502 and CHE505 next semester. Okay, it will change your reactor into your desired product. Okay, ni yang kamu belajar untuk CHE502. Okay, so after the reactor, so you know that coming out from this reactor is the product. Okay, and also the remaining reactant, kan, tak semua reactant yang kamu tambah akan will be react. So you have all these sort of things. Okay, so that's why you need the separation process. Okay, so these two subjects is a really important subject, especially during your part 7 and part 8 when you have your plant design subject. Okay, so waktu plant design subject ni you are working in group, and you will give it a title. Okay, you need to work out what kind of unit op involved. Okay, so this kind of unit op, okay, untuk separation process, it can be anything lah yang sesuai dengan proses kamu. Okay, the most famous one of course lah kalau separation ni, of course the DC, which is distillation column. And then you have the gas adsorption, and you have the adsorption and everything lah. So kalau tengok, okay, inside this separation process, you will cover 5 different type of separation. Okay, so the first one is the distillation column. Okay, so here we're gonna spend 3 weeks, which is from week 1 until week 3. Okay, and then okay, if you can see here, there is a notation here, the assignment 1 means here you need to know that your assignment 1 is solely on the topic 1, which is a distillation. We'll cover the distillation. All right, and then the second process, okay, we're gonna spend it on during minggu keempat hingga minggu keenam, which is the process of the liquid extraction. Okay, and after that you're going to have your midterm assessment. So your midterm assessment will cover this both topic lah, distillation and liquid extraction. Okay, so the third process, okay, is leaching. All right, so you need to learn about the concept of leaching and everything. All right, so you're going to have your assignment 2 here. Okay, assignment 2 here for during your week 9 until 10. Okay, so inside the separation, okay, for the separation subject, okay, your assignment 1 is in group. Okay, your assignment 1 is in a group and your assignment 2 is individual. Okay, kita balik dengan mass transfer sebelum ni lah. And if you can see that that's why, okay, your assignment 1, the contribution is 30%. Okay, so it's quite hard, 30%. However, as you know that even though that your assignment is in group, that your final mark is actually individual according to the peer evaluation. Okay, and then your assignment 2 is 20%. Alright, so untuk final assessment is similar like other subject, 40%, or your midterm assessment is 10%. Okay, so as you can see here, that the assignment was very specific to a distillation column, because distillation column is really important as a, as a chemical engineer. It is the design of then understanding of distillation column is very important. And your MTA will cover these two topics. Alright, then we have the leaching, and another 2 weeks for membrane separation. Okay, we need to learn about introduction and type of membrane, what's the classification of membrane, and then we have the last one is the crystallization. Okay, crystallization is the process, the equipment, we call it a crystallizer. How actually the function of how actually the crystallizer can function in order to separate the material. Sama juga dengan membrane ni. Okay. Alright, so I think we have, kalau macam sebelum ni in mass transfer, the first 6 week you learn about the fundamental knowledge of the mass transfer, right? All the diffusion, convection, okay? And then the last 3 topics that you only learn about the design, kan, and unit op lah, which is the process of absorption and drying. Okay, but this separation process, okay, CHE544 ni, all the 5 topics that you're going to learn about the separation process. Okay, so kalau ikutkan sekarang ni, all together, you have learned by the end of this semester, you had learned 8 different process lah, kan, sebab 3 daripada mass transfer and 5 daripada separation process. Okay, alright, so alright. Okay, you can read this synopsis. Okay, and then the objective. Okay, you must be able to describe various type of unit op. Okay, various type of unit op. Maksudnya sekarang ni at the end of the subject dah boleh faham lah distillation macam mana, liquid extraction, leaching and everything. Okay, and then apply chemical engineering calculation. Okay, of course lah, nanti kita ada design everything. And then finally is that evaluate unit operation for separation process. Okay, so this one ni pun you akan apply dalam subjek ni, and juga you akan apply dalam subjek plan design nanti. Maksudnya when you have a system, you need to decide what is the best unit op. You need to evaluate, you need to evaluate what is the best unit op for your specific process. Okay, nak guna DC ke, nak guna adsorption ke, nak guna membrane ke, for example. Okay, so at the end of this semester, you need to have this 3. Okay, this is the expectation at the end of this bukan kelas apa, at the end of the semester. Alright, so here this is all the syllabus. Okay, contents, and then this is the distribution marks percent. So we're going to use a WhatsApp and Microsoft Team. Alright, sampailah final assessment nanti pun kita akan hantar final assessment dengan assignment tu pun you akan hantar guna Microsoft Team. Alright, so the textbook used as I mentioned previously in a mass transfer, dia adalah buku yang sama dengan kamu guna waktu yalah waktu mass transfer hari tu, which is again copies. Okay, so alright, so buku ginkgo copies ni saya cakap hari tu berbaloi kalau beli sebab you're gonna use it for last semester and this semester. Okay, however I expect that each one of you dah ada dia punya soft copy. Okay, because you know the notes and the problem sometimes I'm gonna ask you to do some problems inside the books. Okay, for the tutorial class, so you need to refer to the textbook. Okay, and then I hope that each one of you right now dah ada soft copy, at least lah. Hard copy lagi bagus sebab you doesn't manage to get it, and then soft copy is just fine. Okay, so for this distillation process, okay, kalau dalam buku tu is refer to the chapter 11. Okay, chapter 11 will cover on the, this is refer to the ginkgo copies. Okay, so basically maybe dalam week 1, okay, we're gonna spend from 1.1 to 1.4, okay, and then we're gonna spend 1.5 to 1.6 in week 2 and 3. All right, and then for liquid extraction, okay, if inside the ginkgo copies you refer to the chapter 12, all right, from subtopic 12.5 to 12.7. Okay, sekejap kalau saya tengok buku tu sekarang. Sekejap Boleh buka chapter 12, bikin copy please. Okay, so from subtopic 12.5, alright. You pun boleh buka punya soft copy ataupun you punya buku. Okay, under the subtopic single stage liquid extraction. Okay, so it will cover. Okay, we're gonna learn on how to extract this thing sampailah 12.7. Alright, 12.7 apa dia? Continuous multi-stage countercurrent extraction. Okay, so untuk yang seterusnya, okay. For leaching is also known as solid liquid separation. Okay, this one is liquid extraction. So kalau leaching is a solid liquid. Okay, so this one is again chapter 12 juga. Okay, dalam green copies too, but it will cover from subtopic 12.8 until 12.10. Okay, so kalau tengok sini 12.8 dia start dengan apa? Okay, so maksudnya kalau dalam buku tu kita bersambung je lah. Stop dekat 12.7 and then kita sambung dekat 12.8. Okay, introduction and equipment for liquid solid leaching. Okay, so you kena tahulah kalau topik leaching you are talking about the liquid solid separation. Okay, topik number 3. Kalau topik number 2 tu liquid extraction. So dia cover daripada subtopik 12.8 until 12.10. Sampailah countercurrent multi-stage leaching. So basically the syllabus cover untuk chapter topik 2 dengan topik 3 ni sama. Which is we're gonna cover on the single stage and the multiple stage. Okay. Apa nak cakap tadi? Okay, untuk membrane separation. Okay, so membrane separation ni is a bit different. Okay, nak compare dengan topic 2 and topic 3. Alright, because we are talking about different kind of separation concept. So this one you need to refer to chapter 13. Alright. We're gonna cover our syllabus will cover from subtopic 13.1 until 13.3. Okay. So if you flip through the book, chapter 13, okay, is under, okay, chapter 13 dalam green copies memang the title is membrane separation processes, okay, but we're not gonna cover the whole things, okay. Of course, we just cover from the basic one, okay, the introduction to membrane, 13.1 until 13.3, okay, until gas permeation membrane process. Alright. And the final one is chapter 12, which is the crystallization process. Okay, crystallization is the process. The equipment, we call it as a crystallizer. Okay, so it is back to the chapter 12. Okay, and from 12.11 until 12.12. Alright. Alright, so unlike previous topic, crystallization is also a different kind of separation process. You need to understand a bit difference lah about the concept and about how it actually works. Alright, and then so this is the book that we're going to use. Okay, when I say chapter 12 and everything is referred to this green copies. So beside this textbook, you have another reference book that you can look out into, okay, for more understanding, especially on the understanding of the concept and fundamental. Alright, so additional information. Okay, I know you already get used with this kind of ODL activities, but just want to mention it once again because it has been our third time, okay, doing this ODL. Okay, that the participation in ODL activities is compulsory. Okay, sama juga macam sebelum ni. Kalau we have the face-to-face classes, then you need to have 80% attendance. Alright. Consultation by, okay, consultation is by appointment ni, I'm not so rigid lah. I mean, you can just simply WhatsApp me private if you have some kind of question, and I will reply bila mana saya ada masa. Okay, so you know that any form of cheating and plagiarism will be penalized. Alright, so I think it's clear. Okay, so far, do you have any question for the syllabus? Ada nak tanya ke tentang assignment 1, because dia big difference lah. Assignment 1 group, assignment 2 nanti individual. Tak ada apalah, just change in the markah tu je lah. Saya rasa nak compare dengan mass transfer. So any question before I go to the second file here, which is on the complex problem solving? Ada soalan tak? Tengok sikit apa orang dah masuk. 27. How many of you actually? Alright, tak ada soalan faham? Okay. Then we go to the next part. Alright, this part is actually even for me is relatively new for me to officially share this thing with the students. Okay, but it's now compulsory. And I think that kita dah hari Rabu, okay, mungkin hari-hari sebelum ni, when you have another class, I think that the lecturer also explain to you about this thing. Alright, so it is about, because you know that this coming September there will be a visit from EAC, okay, which is stand for Engineering Accreditation Council, and it will come and evaluate our syllabus, our approach of learning, because you know that to get the bachelor degree in chemical engineering, you have altogether 8 parts. Okay, so you can see here that this online distance learning, okay, mula-mula ingatkan just 1 semester, and then you know we have 2 semester, and this is our 3rd semester for ODL, and it's about, you know, already half of your program. So hopefully nanti you are quite lucky, because your part 1 you have full face-to-face program, and then part 2, 3, 4 yang start ODL, and hopefully your part, bila kamu dah masuk part 5, 6, 7, 8 nanti, it will be, the things will be get to normal hopefully. Okay, so you know there is some kind of like changes. Okay, kamu pun boleh nampak perbezaan berlaku dari segi our landscape, okay, the education landscape. Okay, so when the council come to faculty this September, actually why the lecturer needs to explain this thing to student, because the council might randomly pick up a student and interview, okay, what, you know, all this thing. Alright, so kalau kamu pernah dengar lah sebelum ni, I hope that you have heard it before, the words OBE. This OBE is stand for the outcome based education. Okay, means that before you learn about something, you have some kind of like know what is the expectation of this course, of the subject, and of course and also you know what is the expectation at the end of this program. Okay, so sebelum ni, I think you are quite familiar with this symbol PO1, PO2, kan? Kalau nampak, biasanya sebelum ni kita practice kita dekat final examination, okay, dekat question 1 tu kita akan letak lah. Alright, question 1, PO1, CO1 and C2 for example. But right now, I think the last semester and the last 2 semester, I think every assignment, midterm assessment, we already put this thing. Okay, so I hope you at least mana tahu, okay, rezeki dipanggil untuk interview by the council, okay. So at least when you heard about this thing PO, you know what is actually stand for, okay. So this PO is actually stand for the program outcome. Means that what is the expectation, okay, for the student at the end of part 8. Maksudnya bila kamu graduate nanti, apa yang kita nak kita punya graduan ni jadi. Okay, so if you can see here, okay, for the for the separation process, it's actually we have 12 PO altogether. Kan, the total we have 12 PO, 12 program outcomes. But you can see that for the separation process, okay, the subject is quite similar ataupun quite straightforward lah, means that we have 3 hours lectures and 1 hour tutorial. So kita tak adalah involve another thing macam plant design, research project, you know, ataupun macam laboratory work yang melibatkan psychomotor skill and everything. Okay, so for this kind of subjects, similar like, you know, mass transfer, heat transfer, CPP1, CPP2, okay, usually you will only get involved with this first 2 PO. Okay, so PO1, PO2. So tak kisahlah kamu total ada 12, tapi kamu kena familiar with this PO1 and PO2, which is the first one is the apply knowledge. Okay, and because of this ODL thing, okay, so you can see that all the assignment, all the assessment is carried out online. Okay, so there is some changes in the program outcome that you can see that the keyword is now that the student must apply the knowledge to solve a complex engineering. Okay, this keyword is a complex engineering. Okay, and sama juga dengan PO2. Okay, you need to identify and formulate. Okay, semua juga keyword dia ada perkataan complex chemical engineering problems, kan? So biasanya soalan-soalan kompleks ni, engineering ni dia lebih sesuai. Sekejap ya. Dia lebih sesuai lah dengan our education landscape currently, which is on the ODL. Okay, so it means that kalau macam dulu the question might be relatively easy and straightforward because you have a close-ended question, right? Kamu datang ke Dewan Peperiksaan, you leave all the notes outside, duduk dalam tu 3 jam, and the answer is actually solely on your understanding. But right now, because of the concept open book semua ni, right? So actually the way, okay, the way we create the question, okay, kena berubah lah supaya orang kata that you get to have an you get kamu boleh masih lagi boleh ada, you can get access to the references, okay, to the notes, but actually how you're going to apply that kind of things to solve this complex engineering name. Alright, okay, so this is the cost outcome. Okay, so kalau PO stand for the program outcome, this CO, if we have CO stand for the cost outcome, means that what is the expectation, okay, for the student at the end of this semester lah for this subject. So you can see here you have 3. So basically that you have CO1, CO2 and CO3. The first one, you must be able to describe various type of unit op and then apply calculation here, and then number 3rd one is the evaluate unit op. Okay, so bila ada proses tu, you need to know, okay, what kind of unit op yang mana yang paling sesuai. Alright, so you can see here that all these elements CO1, CO2, CO3 will be asked during your assignment 1. Okay, and all these elements also will be asked during your final assessment. Alright, but for your midterm assessment, okay, the question is on CO2 and CO3, and for your assignment 2, okay, is solely on the CO3, which is you need to evaluate the unit op for separation processes in chemical engineer. Okay, so all the delivery methods for this subject is by using the online teaching and learning. All right, so okay, now what make a difference with before is that this existing of this CPS. Okay, so when you heard the word CPS right now, I hope you can get an idea that kalau you know that what is OBE now, and CPS is a complex problem solving. So this element again must be included, okay, specifically inside your subject, and for this subject it will be specifically included inside your assignment 2, okay, which contribute to 20%. All right, and then Alright, back to this the thing CO1 and PO1 here. Okay, so this is the cognitive level. Okay, cognitive level we level as a C1 until C6. So kalau tengok soalan sebelum ni, usually, alright, the PO1 and CO1 is usually mapping to the C1 and C2. Alright, so basically when the expectation from the program is the PO1, and expectation of the course outcome is the CO1. And when we talk about the describe various type, okay, usually the question that might be asked is on the knowledge and understanding. And it's stated here that usually the C1 and C1 and C2 level is the easy. Alright, so that's why lah macam kan sebelum ni kamu mass transfer ada benda pun ada benda yang sama. But unfortunately some students okay just neglect this kind of question. So dia tak berminat untuk menjawab soalan-soalan berbentuk tulisan, semua nak kira. But sometimes they get unlucky, soalan kira pun salah, soalan C1 C2 pun tak jawab, okay last tak dapat markah. Alright, so basically if you can see that this CO1 is very important. Sebab you see here that it will be asked during your assignment 1 and dengan final assessment. So by knowing this kind of thing, actually the student can make some kind like a prediction lah. Okay, maksudnya macam, okay, soalan-soalan berbentuk understanding, knowledge, for example, briefly explain what you understand about the membrane technology, okay, and everything. Usually that kind of question will be asked only in assignment 1 and final assessment. So nantilah, let's see bila kamu nak study final assessment, okay, you want to know, okay, perlu ke tak nak cover bahagian-bahagian ni, okay, perlulah maksudnya. Alright, so it different with the midterm assessment. Okay, bila midterm assessment ni, nil, kan? Maksudnya tak ada elemen CO1 ni di cover. So you know, okay, that midterm assessment, the question cover might not ask, you know, about all this definition ataupun give an example. Alright, but the concept of the question will be asked you on the here. Okay, PO2 C4 dengan PO2 C6, which is cover the CO2 and C3. So biasanya kalau soalan-soalan yang melibatkan CO3 ni, okay, CO3 and C6 level ni, so you know that the difficulties, okay, is the medium and high. Alright, that's the things lah. And finally, okay, for the assignment 2, alright, you have this additional elements, which is we call it as a CPS, okay. Like first, for this particular subject, okay, the resource person already choose, okay, it must have the element of WK3. Okay, you need to have a knowledge profile. Knowledge profile ni maksudnya a continuity of the understanding that you have learned before. Maksudnya mass balance, bawa ke mass transfer, bawa ke design of equipment, okay. Maksudnya ada dia punya sequence of the knowledge. Alright. So WP1 mesti ada element of WP1, okay, depth of knowledge required. Maksudnya kamu kena ada ni lah, sedikit orang kata apa, kamu kena ada knowledge, okay. And WP2 range of, salah eja ni, range of conflicting requirement, okay. Soalan-soalan dia berbentuk konflik, for example that contohnya kan sebelum ni kan mass transfer, okay, gas absorption, okay, you need to design it in order so that the gas, okay, coming out from the top stream is meet to the requirement. Tapi macam mana kalau tiba-tiba something jadi, you know, conflict requirement, okay. And WP3 is a depth of analysis required. So you can see the WP3 ni, okay, actually dia punya elaboration lagi, there is no exact answer, okay. No exact answer means that even though that you receive the question, you can see that it's similar, okay, semua orang dapat soalan yang sama, but actually there is no exact answer for that kind of a problem, okay. It depends on what kind of unit op that you want to select, okay. Where do you live, what is your data, your reference data, okay. Some get the data of equilibrium data from these journals, some from this different journal, and also the decision of the, for example, operating temperature and pressure, okay. Some choose this operating temperature and pressure. Alright, so it might be quite difficult, but I think that these things really will be really helpful for you all to have your preparation, okay, untuk your design project nanti when you are in part 7 and part 8. Okay, so so I hope that by telling you all this thing, okay, I hope that you can get at least some expectation ataupun kamu boleh jangka lah soalannya. So dengan harapan bila keluarlah soalan tu, kamu bolehlah jawab according to the level. Okay, maksudnya bila soalan maupun soalan assignment tu yang ada elemen this complex problem solving, but your answer is very simple, very direct, not answering the question, and you can expect that it's just something wrong with your answer script lah. Alright, so ya Allah, dah 40 minit saya terang pasal ni. Okay, so I hope that I have played my part, okay, by telling you with the students about all this thing, okay, because it's very compulsory. It's compulsory now for the lecturers to share this thing with the student. So all right, any question? Ada soalan-soalan yang
Madam,
yeah?
saya nak tanya tentang assignment 1 tadi. Satu orang berapa grup kan? Satu grup berapa orang?
Biasanya untuk saya punya kelas, saya biasanya 4 hingga 5 orang.
Oh, okay.
Okay. Sekejap ya. Sorry, saya nak confirmkan balik. I think separation punya subjek ni, I think both assignment 1 and assignment 2 in group. I think tak ada individual. Sorry, can you give me a minute? Nak check balik. Yes, I'm sorry. Okay. Okay, untuk separation process ni, I think I'm a bit confused with the mass transfer. Okay, both assignment 1 and assignment 2 is in group. Okay, however, okay, for assignment 1, okay, you need to prepare a report, okay, macam sebelum ni lah, 10 pages report and everything. But your assignment 2 is actually you need to deliver in a group, in a video. Alright, video group, whereby however that there is a individual marks, okay, ada group marks and individual marks for assignment 2. Alright, here, okay, assignment 2 here. Okay, this is what we have discussed. Ni lah, kalau ada perubahan, I will I'll keep you update. Okay, so that it must be in a video. Pun group juga. I thought it's individual. No, it's not individual. Group. Okay, and then video. That but this video ada markah group, ada markah individual. Okay, and it's compulsory for me to set up a question and answer. Okay, after I watch your recorded video ni, okay, and then I will set up with a different group, okay, that you need to have this question and answer session lah, and this question and answer ni will be individual mark. Okay, and then dalam video ni pun make sure that each one of you need to involve. Maksudnya tak boleh lah maksudnya nak involve tu maksudnya kena appear, your face and your voice need to appear inside the video. Okay, that's ada individual mark juga kat situ. Okay, clear ke? So you can see the difference between the separation and mass transfer sebelum ni. Alright, and then betul tak soalan ni? Tak nak tanya, ini synchronous ke? 24 jam ke? Okay, your midterm assessment synchronous, okay? Maksudnya you need to complete macam sebelum ni lah, bukan 24 hours. So, but the duration of this midterm assessment either it's 1 hour and 2 hours, nanti saya nak confirmkan balik. But I can say in overall, in terms of the assessment, it's a bit different compared to mass transfer before. Where's your final assessment? Okay, your final assessment is also synchronous, okay? Your final assessment is also synchronous. So you know, final assessment synchronous, you have 2 hours, 3 questions. Okay, you have half hour to read the question and a half hour to upload. So total you have 3 hours altogether. Alright, apa lagi ya? I think that's all. Okay. So you know that the separation processes ni sama juga macam saya lepas mass transfer ada banyak kelas kan, 13 classes. So sama juga separation processes. Ada banyak. So far we have a 6 lecturer. Okay. They're going to teach you the subject. Okay. The coordinator is Puan Nurul Ashikin. And another lecturer is myself, Dr. Nur Hidayah, Dr. Harumi, Dr. Umi, Puan Adib, and Puan Siti Fatimah. Okay. Alright. Alright, so tak ada soalan ya? So can we take 5 before we continue our lesson? Kalau persoalan boleh tanya.
Hello.
Ya.
Madam, saya nak tanya berkaitan attendance.
Kenapa?
Nak isi kat mana ataupun madam just download attendance list ni?
Oh, saya download je attendance list ni. Sekejap mana contohnya. So far saya download lah. Download attendance list. Okay. Ini untuk synchronous meeting. Kalau asynchronous meeting biasanya kamu punya attendance tu in term of proof of kerja lah. Contohnya kalau macam kelas hari tu saya buat dalam bentuk tutorial, saya suruh kamu buat soalan kan. Okay, when you submit the tutorial and then that one is considered as a proof of attendance. Okay. Dan adalah nanti, and mungkinlah nanti kita minggu pertama, kedua ni kita buat semua synchronous lah, kita buat online semua. So minggu ketiga sampai minggu ke-6 tu kan bulan puasa kan. So mungkin dalam seminggu sekali juga kita jumpa yang online ni. Okay, mungkin yang tak kisahlah, saya recordkan dulu video tu ke, okay, malam tu, and then just upload and you watch it, and then we met during the second class masa tutorial ke, okay. And then untuk 7-8 you punya ada midterm assessment, and then start minggu ke-9 dan ke atas tu kita start balik synchronous online learning, okay. Special sikit lah bulan puasa, tak larat saya nak cakap direct 4 jam. Alright, so ready dah ke? Nak belajar? Sikit je, okay. Dah bersama kelas hari ni. Just a brief introduction dekat lecture 1 ni. So,
Hello, madam.
Ya.
Nota-nota semua tu nak ambil di mana?
Oh, saya dah upload dah. Dah upload dalam yang punya Microsoft Team ni. Sekarang you boleh nampak tak skrin saya?
Nampak, doktor.
Nampak Microsoft Team kan? Bukannya OneNote, betul?
Ya.
Alright, so you go to your files lah.
Itu OneNote. Saya tak nampak Microsoft Team.
Oh, okay. Sekejap saya ubah setting sekejap.
Madam,
Ya.
saya nak tanya.
Ya.
Kelas jam 10 hari Rabu ni kan, hari ni je ke ataupun the whole sem?
Kalau boleh saya nak the whole sem. Boleh?
Okay, madam.
Alright. Okay, so sekarang nampak skrin saya dekat Microsoft Team. Am I right?
Yes.
Ya.
Kita pergi dekat files. Okay, so class materials. Okay, now download it right now. Lecture notes. Topic 1. Okay, topic 1 ni distillation, kita kena ada apa? Lecture, ada 4 file saya upload kat situ. Okay, download sekarang. Buka dulu, baca sikit-sikit. Okay kelas, dah jumpa note semua Boleh?
Boleh ada.
Jumpa madam, jumpa.
Right, so sekarang ni kita buat kelas sikit je, okay. Biasanya saya kalau kelas pertama saya macam biasanya cerita pasal lesson plan je. Tak apalah. Nanti kita buat sikit je, okay. Kita stop sampai example 11.1-1. Right. Tak payah masuk lagi single stage. Alright. Alright, now santai je. Alright, this is the first lecture of distillation column. So saya nak repeat sekali lagi yang the knowledge that you learn from this topic is very useful. Okay, so biasanya pengalaman saya bila saya guide student untuk buat design project, memang tak nak chemical process, especially you all ni bukan student bio kan, you all memang chemical process and design chemical. Distillation column ni macam boleh dikatakan wajib punya equipment lah untuk kamu select dalam ni. Ada juga yang lain kena ada yang select gas absorption, okay, ada select ni, tapi distillation column ni boleh saya katakan sangat penting lah. Okay, okay, alright. So for an introduction, okay, so I think semua kat sini faham kan the concept of a distillation column. Okay, this is a process in which liquid, okay, maksudnya biasanya kita, kalau you have the column, okay, and then akan masuk is a bentuk of liquid form. Alright, so this is the definition. Alright, it's separated into its component fraction. So you can see that usually dia akan biasanya ada bahagian atas dengan bawah. Alright, and then by the application and removal of heat. Alright, so distillation principle here. Okay, this is introduction. I think the definition of the distillation column ni you can simply check it out from any references kat internet, banyak semua. Okay, so the most important things about distillation, okay, both here is difference in boiling point. So you know that the separation process, okay, inside the distillation column is based on the boiling point, kan? So biasanya kalau boiling point rendah, dia akan, when you supply the heat, so that the low boiling point will be volatile first and go to the upward kan. Okay, untuk boiling point tinggi dia akan stay and then dia akan coming out as a liquid at the bottom of the column. Okay, so the keyword here is that the difference, we manipulating the difference in boiling point in distillation column so that the mixture can be separated into their individual components. Okay, so untuk distillation column not necessary ada top and bottom je. Okay, sometimes it's very complicated, dia ada banyak lagi stream. Okay, so when you have this kind of liquid, okay, multiple mixture coming in, okay, so the lowest boiling point akan keluar kat paling atas lah. Okay, this one is the lowest boiling point, and second lowest boiling point akan keluar dekat sini, you know, sampai lah dekat sini is the in liquid which is have a highest boiling point. Alright. Okay, so the distillation process depends on the vapor pressure characteristic of the liquid mixture. Okay, so here in the distillation column, kamu kena faham concept of vapor pressure. Usually we label this one as a PA. For example, this is the vapor pressure of component A. Okay, or PB. P ni besar, capital P is a vapor pressure of component B. Right. Okay, so the most common example in a chemical plant, okay, ethanol water solution. So by right kita tahu kan ethanol ni boiling point dia lagi rendah daripada air. Alright, so eventually when you supply heat, okay, to the column, okay, so eventually the ethanol will vaporize first and going up to the top of the column. Alright, so ni simple distillation process lah. Example, okay, ammonia and water. Ammonia akan vaporize dulu. Alright. Alright, so at the end of this topic, okay, we want to design, okay, the distillation column, how many stages required, how tall the column might be, okay, what is the reflux ratio and everything. So that kind of thing need you to have this vapor liquid equilibrium. All right, this is what we call as a VLE. Okay, what is means by this VLE? Okay, so of course lah, nama dia equilibrium means that the condition in which liquid and its vapor is in equilibrium lah. Okay, so when you have let's say a condition, okay, rate of evaporation is equals to the rate of condensation. Okay, maksudnya kalau rate of evaporation tu maksudnya the rate of liquid change into the vapor is similar to the rate of the vapor condense back into the liquid. So this specific condition, okay, this specific condition we refer as a vapor liquid equilibrium, and it will be different according to the temperature and the system. Maksudnya sistem kat bawah ni contohnya sistem benzene toluene. Okay, this is their system. Okay, this is the value. Okay, alright, this is their equilibrium curve. Okay, so kalau you are talking about different system, for example ammonia, water and everything, and then this value might be different. Okay, the equilibrium curve might be different. Okay. A substance, okay, boleh baca ni. A substance at vapor liquid equilibrium is generally referred. Okay, baca dua ni dulu. And hadamkan dulu. Okay, so faham the definition of saturated fluid. Okay, you have saturated fluid and you have saturated vapor. Saturated fluid is about to vaporize. Maksudnya, a condition when you just add another heat and then the liquid will start to vaporize. That's the saturated fluid. So saturated vapor maksudnya you just remove a heat from that system and then the system, okay, the vapor is start to condense. Okay, that's the term of saturated fluid and saturated liquid and saturated vapor. Okay, so this equilibrium curve showing you the relationship between the composition. Okay, sorry. And you know that this curve, okay, will be useful in calculation to predict the number of the other stages required. Okay, kenapa pentingnya kamu nak faham tentang konsep vapor liquid equilibrium ni? Because later on during the design of the distillation column, you need to have this VLE data. Alright. Okay, now so this is the example of equilibrium diagram for system benzene toluene at this specific temperature. Okay, so usually this kind of thing will be given dalam bentuk table atau dalam bentuk graph. Okay, so this thing you can actually extract lah the information from this graph or from this table so that you can use it later on during the calculation. Okay, alright. So actually this is the 45 degree line, but actually the equilibrium diagram is referred to this curve line. Okay, this curve line. Alright. Alright, so now we go to the boiling point diagram here. Okay, boiling point diagram here, okay, shows you a relations for binary mixture of A and B, okay, are given as at boiling point diagram. Okay, for example here, tadi is the Y mole fraction in vapor YA versus XA, okay, of benzene, right? Okay, this diagram you can have two information, which is the temperature versus mole fraction, and this mole fraction can be either SA or YA, because here, okay, you have the vapor region, is that the component exists in vapor. You have a liquid region, which you know that behind this line, okay, this area, that all the components exist in liquid form, okay. So you have a vapor liquid mixture region, okay. Maksudnya between this saturated vapor line and between the saturated liquid line, you have a mixture of vapor and liquid, okay. So means that here for this specific, okay, so I want to tell you again that this diagram is specific only for the case of benzene and toluene. Untuk case lain, then the diagram will be different. Alright, so for example here, you can actually read this. For example, that if this process occur at temperature T1 here, okay, so kamu tarik pergi dekat sini to this saturated liquid line and drag it here, it will give you the value of XA1, okay. And then when you bring it to a saturated vapor line, and this value will give you the value of YA1. Okay, so you have two important diagram here. The first one is YA versus SA. Okay, and this diagram I think you familiar before. Masa kita buat gas absorption sebelum ni pun kita ada graph ni kan, YA versus SA here. And then the second diagram is the temperature versus the mole fraction. Okay. Okay, untuk isotropic ni saya nak skip dulu. This 3 slide, kita akan datang balik. Alright. So right now, sikit je lagi saya nak stop sampai dekat kita buat latihan kat sini je. Alright, kat sini je, and then we end off our class. Okay. Now, please give focus here, okay? Because this is very important about the Rod's law, okay? Prediction of vapor liquid equilibrium. Okay, this law can be used to calculate the composition of liquid and vapor which are in equilibrium. Okay, dekat sini you can see here that you have a small p, right? And you know that this small p refer to the partial pressure of A in vapor phase. Okay, let's say that you have a container, okay, a closed container, and inside here you have a mixture of A plus B, and this mixture, you know, evaporate and become a vapor, okay, so that it will create the PA and PB. So you know that the partial pressure of A is caused by the molecule A, and partial pressure of B is caused by the molecule B. So you know that the PA plus PB is equal to capital P here, which is the total pressure of the inside the system, right? And then you have the XA here is the mole fraction of FA in the liquid phase. So everything in liquid will label as XA and also the XB. So same thing lah, SA plus XB must be equal to 1 instead of the mole fraction. Okay, so right now, as I mentioned here, okay, we have the capital P here, PA. Okay, so we have also the PB, vapor pressure of B. So this PA and PB, okay, don't get yourself confused with this PA. Okay, so PA is a partial pressure. PA plus PB is equal to total pressure. But this PA and PB, okay, it's not a partial pressure, right? So it's actually depends on the system. Okay, so usually this value of PA and PB, all right, will increase as the temperature increase. Okay, so for example here, ada buku kan sekarang pun tak tengok dekat contoh example 11.1-1 ni. Refer to the table 11.1-1. Can you flip your book right now or go to your PDF books? Okay. Tajuk dia, the title of the table is Vapor Pressure and Equilibrium Mole Fraction Data for Benzene Toluene System. Okay. So you can see here, okay, as the temperature increase, okay, if you refer to this table, okay, I'm sorry, it doesn't have the table right now with me to show you, okay, but if you refer to the book, okay, as the temperature increase, you can see that the value of PA and PB is increased, right? Okay, so so the relationship between the partial pressure and the vapor pressure with the mole fraction is PA is equal to SA PA. All right. So alright, so this, as I said before, PA plus PB is equal to P, total pressure. PA is a partial pressure. So this is equation number 1. Yeah, you need to know. So you know that PA SA plus PB SB. Okay, but you know that SA plus SB is equal to 1. So SB is equal to 1 minus SA is equal to P. Okay, this is equation number 2. Okay, and then you know that the YA is equal to PA over P, right? If you still remember the one that you learned before, okay, YA means that mole fraction of A inside the gas in vapor. If you multiply by the total pressure, it will give you the partial pressure of A, right? So means here, YA is equal to PA over P is equal to PASA over P, because PA here is equal to SA PA here. So here it will shows you the relationship. Okay, this one is the equation number 3. So this equation, okay, this Stokes law ni, will show the relationship between the total pressure, P ni total pressure of the system, PA is a vapor pressure of A, okay, YA is a mole fraction of A in vapor, SA is a mole fraction of A in liquid. Okay, so I think right now you just must clearly know that small PA, small P, which is partial pressure, tak sama dengan PA. Okay, PA ni lebih kepada macam bergantung pada fraction, kan, fraction. Okay, so that PA plus PB is equal to 1. But PA here is a vapor pressure. It depends on the system and the temperature. Okay, so usually the value of PA and PV, vapor pressure ni kita akan dapat daripada table ataupun graph. Faham Okay, that's the first thing that you need to know about this vapor liquid equilibrium that you can calculate sometime by using the Rod's law. Alright. So, nak faham sekarang ni, go to the example 11.11. Okay. Kita nak cuba apply this first 3 equations so far. Okay. The equation is just simple. Okay. Calculate the vapor and liquid composition in equilibrium at 95 degrees Celsius for benzene toluene using the vapor pressure of the system. Okay, available at table 11.1-1. Alright. So sekarang ni disuruh cari apa? Disuruh cari SA dengan YA. Kan? Vapor and liquid composition. So vapor and liquid composition ni maksudnya this one is SA. This one is YA. Liquid is SA. Okay. So macam mana kita nak buat? Okay, dia dah bagi specific temperature kat sini. Okay, right now, kalau kamu tengok table tu kan, betul sekarang ni semua tengok table tu. Cuba tengok, dekat temperature 368.2 Kelvin, which is on the 4th row. 4th row. Okay, at T368.2 8.2 Kelvin. Do you spot the value of PA is equal to 155.7 kPa? Okay, PA, A here refer to benzene, and PB, B here refer to toluene, give you 63.3 kPa. Okay, dapat tak value ni? Dapat kan? Right. So you just simply put this value inside this equation number 2. Right. So maksudnya 155.7 SA plus 63.3 1 minus SA is equal to P 101.32. So you solve this equation, you will get the value of SA. Alright, SA refers to the benzene. So what value of you get for the SA? Okay, senang je. Kamu akan dapat the value of SA is equal to 0.411. Okay, just a simple equation here. So you know that the SB is equal to 1 minus SA. So eventually you will get the value of SB. Okay, so next we can use this third equation. You know that YA is equal to PA SA over P. Alright. So in order for you to get the composition in vapor, okay, vapor composition for A. So what is the partial pressure here for A at this specific temperature is 155.7, right? So multiply with the value of SA that you get 0.411 and then divide it by the 101.32. Okay. So you solve this one, eventually you will get that the value of YA is 0.632. Then of course YB is equal to 1 minus 0.632. Alright, so by this simple example, I hope that you can differentiate between the partial pressure and the vapor pressure. Okay, so the keywords here is that partial pressure and also the vapor pressure. So usually this one is capital P, partial pressure is the small p. Alright. Okay, now boleh faham? Ada soalan? Can you get it so far?
Madam.
Alright. So ni last example kita buat sebelum kita habiskan kelas. Okay. If you really understand, okay, what you have learned before on how to apply equation 1, 2, 3 here, okay. So can you answer this question? Okay, this is the question and this is the answer, okay. You can use your Microsoft Excel, okay, tak perlu. You can calculate and use the Excel to plot these two diagrams here. Alright, so this is the, redundant sikit notes ni, okay. This is the data for vapor pressure for the system heptane and octane. Okay, kalau dalam table previously in tables and as I said before that the nature of it as temperature increases, so usually the partial pressure and the partial pressure of A and B will increase. Alright, so right now the question is a liquid mixture is formed by mixing liquid heptane and liquid octane in a closed container at constant external pressure of 1 atm. Okay, so right now I want you to calculate the equilibrium composition of vapor and liquid. Okay, cuba buat. Cuba buat soalan yang pertama ni, dapat tak jawapannya macam kat dalam table ni. Jawapannya kat sini. Okay, cuba buat question 1 here, 1 Roman here, by using this equation 1, 2, 3 atas ni. Okay, boleh. Okay, by using the this vapor pressure data, okay, you use equation number 2, right? 101.3 SA plus 0, 1 minus SA is equal to 101.32. So you get that the SA is equal to 1. So you know that the YA is 101.3 multiplied by 1. You divide it by 101.3. This one is equation number 2 here. This one is equation number 3. And you get 1. So basically at first row, okay, first row, you get the SA 1, YA 1. Okay, that's the first row. Now you need to calculate for the second row. Okay. Okay, so the vapor pressure is 110.8 and 59.9. Alright, so 110.8. You can use Excel as A. Okay. Plus 56.9 multiplied by 1 minus XA is equal to 101.32. So eventually when you solve for XA, you akan dapat value of ni lah kot 0.824 ni. Okay. So YA here is 110.8. You multiply by the value of SA that you get, bahagi dengan total pressure. So eventually your YA, you should get the value of here 0.901. Okay, so far boleh faham ke macam mana kita nak apply equation number 2 and number 3 here? So if you're done calculating all this, okay, from this table vapor pressure, okay, you can actually convert it into the SA and YA. Okay, now, okay, tak masalah semua. Okay, so now, kalau mana yang laju tu, kita dah siap calculating this data. Can you open your Microsoft Excel, okay, and try to plot these two diagram, okay, boiling point diagram and equilibrium curve. Okay, dapat tak figure macam ni? Okay, so this one is the temperature. Okay, in Kelvin, which is unit this temperature. Kamu kena refer balik lah dekat this first column here. Alright, first column here. And then you know that the x-axis is the XA and YA. Okay, untuk equilibrium curve, you need to plot the graph of YA versus SA. Okay kelas, dah habis develop tak ni this table?
Dah, doktor.
Alright, so I think I want to stop this class only at this example, okay, because I just want to focus on this slow application of the equation that we have discussed before. So please make sure, okay, saya tak check, but please after you have done finding all this value, try to plot it in your Excel. Tak payah buat manual lah, buat Excel je. And compare your answer with this graph. Okay, dapat tak bentuk boiling point diagram macam ni? Dapat tak bentuk A versus SA macam ni? Okay, so basically untuk graph YA versus SA, this one is 45 degree line. Okay, and then this one is, as you can remember, this one is the area of the mixture vapor liquid. Bahagian atas is the vapor, bahagian bawah is the liquid. Alright, so so can you do this at your computer? Okay, just cuba dapatkan ya. So by right, you need to answer this question 1, 2 and 3. So kalau tak dapat apa-apa soalan, I will end this class for today. Okay, so we will continue nanti. Okay, kelas hari Jumaat nanti pukul 8 pagi. Sorry, pukul berapa entah, pukul 8 ke 10. Okay, hari Jumaat nanti kita jumpa. Kita akan cover lecture 1 and kita akan start dengan lecture 2, which is on the cap and tail. Okay, so kalau tak ada apa-apa soalan, kita stop dulu sekarang ya. Alright, Assalamualaikum.
Waalaikumsalam. Terima kasih, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Sama.